collision can be defined as a very short timed interaction. It is a short timed or transient interaction between the objects. For instance, you take the example of a bat and the ball. The ball is coming in this way and the ball goes in this way. Just before the collision, let the ball move in this way, and just after the collision, the ball moves in this way. You can assume their velocities v1 and v2, initial velocity, final velocity of the ball. The mass of the bat, let be capital M. When you take this ball as a system, on the ball there are two forces acting. One, the force of gravity, that is acting downward. Another, the force given by the bat on the ball. This force is called impact force or collision force. And this impact force stays the APS or X so long as the ball is in contact with the bat. This contact, very short timed great force, is called impulsive force. So impulsive force is the force acting on the colliding objects during the process of collision. We can say that practically in many cases the impulsive force is much greater than the gravitational force, which is always acting. This is always acting. This impulsive force acts during collision. This is the difference. The force which always acts can be called non-impulsive force. The force which always acts is called non-impulsive force. The force which acts only during the time of collision or during collision is called impulsive force. Therefore, in the process of collision, we should take the impulsive force into account strongly, disregarding the effect of the non-impulsive forces such as gravity, in general friction, normal reaction. I keep this object on my palm. The force acting on this object, the pen, is normal to the palm and it is vertically directed up. That force is called normal reaction. In addition to that normal contact force or normal reaction force, another vertically downward force also is acting, that is none other than the gravitational force acting on the object or its weight. Weight of the body is down, normal reaction is up, normal reaction is exactly equal and opposite to the weight of the body, because this force is in equilibrium. The acceleration of this body is 0. So long as the body is in contact with my hand, normal reaction keeps on acting on the object in vertically upward direction. And that normal reaction, you cannot call it an impulsive force. Since it is always acting, this normal reaction is a non-impulsive force. Whereas the same piece of matter when collides. During the collision, another normal reaction or additional normal reaction acts on the object. That normal reaction is non-impulsive in nature and much greater than, or at least greater than, the normal reaction acting on the object in general case. And that normal reaction is an impulsive force, whereas the normal reaction acting on the object always is non-impulsive in nature. When you keep the object, suppose 0.05 Newton acts on the object. But when the object collides, it may be possible to experience a force which is much greater than 0.05, maybe 1 Newton, 2 Newton, 3 Newton, more than that, 10 Newton, 100 Newton also. So this sort of forces acting on the objects during the time of collision is called impulsive forces. Therefore, when we deal with the collision to analyze the motion of the objects, to find the velocities of the objects just after the collision, we need to understand in which direction the impulsive forces act. The impulsive forces can control the final momenta of the colliding bodies. However, the non-impulsive forces can be ignored because the non-impulsive forces cannot change the momenta of the objects, colliding objects, significantly during a very small or very short time of interaction or the collision. And I will try my best to explain it mathematically. And for this, we need the concept of impulse of a force that I explained in the last chapter. Here I won't take too much of time to glorify this concept. Impulse of a force is not an impulsive force. That point I need to re-explain. Impulse of a force is a product of that force and the time during which the force is acting. Whereas impulsive force is a force. Impulse of a force is not a force, it is the product of force and time. Dimensionally, this may be equated with the change in momentum of the object. So, force into time or impulse of a force is change in momentum, whereas force is the rate of change of momentum of the object. When you draw the FBD, we have two forces, impulsive and non-impulsive. Just disregard the non-impulsive forces. Take the impulsive force into account. This force is the cause of change of momentum of the ball. How much momentum the ball is changing during the collision? This is just before, this is just after. And the time of collision, let be del t. Time of collision is very small. Let these are the average force. Average force acting on the object, on the ball by the bat is N. So N into del t, this is called impulse, and N is the impulsive force. N is equal to del P by del T. The gravitational force I am ignoring for the sake of simplicity. Since the change in momentum is significant and del T is extremely small, definitely N must be a large quantity. This large force acting on the ball during a time of interaction, during the short time of interaction, is called impulsive force. Generally, impulsive force is a great force. Generally, impulsive force has large magnitude. So while we define the collision, we need to take the help of impulse of a force. Which force? Impulsive force. And its impulse. So this is an illustration. I am giving a very common example of the collision of the ball with the bat. Bat may move, you are swinging the bat in some direction, that be meters. When you concentrate on the ball, this ball is changing its momentum from this direction to this direction. How much momentum this ball is changing? If you divide that momentum, change in momentum, by the time of collision or time of contact of the ball with the bat, you are getting an average force. That average force is very large. And due to that large force, we can say the ball which comes with a finite speed will leave the bat with an incredible speed, and it is extremely difficult for the fielder to stop that ball. Unstoppable. With no time. With the twinkling of the eye, the ball will go to the boundary. And you can enjoy that as grass cutting 4 or 6 also. Effortless. Just by twisting of the bat, we are just giving a great impact force or the impulsive force to just change the speed of the ball significantly, and its direction is also changed very swiftly, so that the ball will go in a very beautiful manner with very great speed, practically unstoppable. So these are the beauty of collision on our day-to-day life. Let us now discuss how many types of collisions are there. We completed definition, and I talked about the impulsive force. Impulsive force has large magnitude, and impulsive force is the force acting on the colliding objects during collision. Since the time of contact or time of collision is extremely small, and the numerator factor, that is the change in momentum of the bodies, is finite, is noticeable, the ratio will be incredibly large or extremely large or generally. Therefore, the impulsive force is a great force. So, after discussing these 3 basic points, let us try to understand different varieties of collision.